Pydantic AI's capability system is the mechanism through which tool definitions are shaped and enriched before reaching a model. And the IncludeToolReturnSchemas capability demonstrates this by injecting return type information into each tool's schema definition. The visible code constructs an agent, registers a plain tool, runs it synchronously, and verifies that the tool's IncludeReturnSchema flag is set. Students will encounter an agent instantiated with a test model, and the IncludeToolReturnSchemas capability passed via the capabilities parameter. A @agent_tool plain decorated function returning a float, a synchronous run against that tool, and an assertion confirming that the resulting tool definition carries its return schema. From Pydantic AI Import Agent. From Pydantic AI, capabilities import IncludeToolReturnSchemas. From Pydantic AI models, test import test model. Test model equals test model. Agent equals agentist model. Capabilities equals IncludeToolReturnSchemas. @agent tool plain. Def get temperaturicity, SDR float. Get the temperature for a city. Return 21. Result equals agent. Run sync what is the temperature in Paris. Params equals test model last model request parameters. Assert params is not none. TD equals params, function tools 0. Assert TD, include return schema is true. This sets up a test agent with IncludeToolReturnSchemas capability, registering a plain tool that returns a float, and verifies the model request parameters include the return schema flag. The capability injects the tool's return type into the function tool definition, so the model knows what to expect from the tool, which matters for providers like Google Gemini that natively support structured return schemas. For models without native support, the schema gets injected into the tool description as JSON text. The trade-off is that including return schemas adds tokens to the request, but it enables the model to reason about tool outputs more precisely. Using toolplain here keeps it simple since the tool doesn't need agent context, and the assert confirms the capability is wired correctly. Let's break it down. From Pydantic AI Import Agent. From Pydantic AI, capabilities import IncludeToolReturnSchemas. From Pydantic AI models, test import test model. Imports the agent class, a tool return schema capability, and a test model for Pydantic AI. Test model equals test model. Instantiates a test model and assigns it to test model. Agent equals agentist model. Capabilities equals IncludeToolReturnSchemas. Creates an agent bound to test model with IncludeToolReturnSchemas as a registered capability. @agent tool plain. Def get temperaturicity, SDR float. Get the temperature for a city. Registers get temperature as a plain tool on the agent, a function that takes a city name and returns a float with a docstring describing its purpose. No agent context is required. Return 21. Returns the floating point value 21. Result equals agent. Run sync what is the temperature in Paris. Calls the agent's synchronous run method with the prompt, what is the temperature in Paris? And stores the returned run result in result. Params equals test model last model request parameters. Assert params is not none. Retrieves the most recent request parameters from test model and asserts they exist. Fails fast if no prior request was made. The IncludeToolReturnSchemas capability exists to inject a tool's return type into its schema so the model knows what to expect. Here you see that pattern in practice. An agent is wired with that capability. A plain tool returning a float is registered with that agent tool plain. And after a synchronous run, the assertion confirms the tool definition carries IncludeReturnSchema set to true. For models that natively support structured returns, like Gemini, the schema goes where it belongs. For others, it lands as JSON text in the description. The trade-off is extra tokens for more precise tool output reasoning, and toolplane keeps things simple since no agent context is needed. The assert ties it all together by verifying the capability is actually wired through.
The schema loads before Paris asks. The toolplane answers 21. The function tools hum, and the model stares at nothing.